Yes.
Okay, so we are live on YouTube. What is the review decision tomorrow? For the exams, I have not been keeping up with exam news because I keep up with things that are in my control. So exam news are not in my control. So I don't keep up with them. You know, there's no, I mean, it's so much happening. It's too early. Who cares, right? Who cares? I mean, at this point, you'll care definitely when you go a little later in the series. Yeah, but right now, we can run with this, right? No, what happened here? Okay, yeah. Sorry, my bad. What happened? This should only show Google Chrome. Yeah. Okay, there it is. Okay, school's opening. Oh, school's opening. That, I'm sorry. I thought you meant the Cambridge exam. I don't know. Okay. Mubarakas, we are now getting to set up the schedule regularly here, and the previous some lessons are on this platform and the others are going to be uploaded onto YouTube. I keep saying that, but it's happening this weekend. Okay, so if you, and I'll put up the link to the playlist in my profile so you can access all the older videos also. Okay, that's fine. So now let's start. How about we start utilization? Okay, so now I know you see a white screen. I'm changing that to a black screen. Okay, so okay, the decision got challenged in the whole High Court. All right, I don't know that. So let's talk about neutralization. Neutralization. Now, where does the name come from? The name comes from the fact that we saw a pH scale, and 7 was pH neutral, and 0 or below were, anything below 7 were acids, and above 7 were alkaline solutions or alkalis. And the term neutralization means to either take anything from above 7 to 7 or below 7 to below 7 towards 7 or above 7 towards 7. So neutralization means neutralizing either an acid to a neutral pH or a base to a neutral pH. That's what it means. All right. Now, so the idea being that if you start with an acid, then what do you end up with? So the idea is that if you're given an acid, can you make it neutral? So the idea was that if you remember last class, maybe we recalled, and I'm going to do this today, but before I do that, it'll be nice to also talk about last class and what was happening in the last class and why do we have two of these. Okay, why do we have two of these? Okay, so if you remember, we did pH last class, right? And the fact of the pH was that we have done some pHs in what you might call it, acid bases, and we saw weak acid, strong acid. Do you guys remember all that stuff, right? So we have, let's say if we have a solution and pHs and solution. So I have a solution with pH, let's say a solution A has a pH 9, B has a pH 3, C has pH 0, D has pH 7. Sorry. Now, if I ask you first before we continue, what kind of solution is A, acidic or alkaline? So the idea is you can either choose acidic or alkaline or neutral. Okay, so A was alkaline, B is acidic. Okay, my pen, something's wrong with the pen, right? The writing is pretty horrible, isn't it? Yeah. Yeah. I got a new tablet to write, by the way, which I can see what I'm writing it also. So let me write slower. And C0 is what? What is Charlie? Charlie is also acidic. Now, obviously, those who know this, it's a strong acid, but it's acidic, right? And what's the fourth one? The fourth one is neutral. So when I say neutralization, the term in English means what do I add? So how can I make B A neutral, or how can I make B neutral? So when I'm saying neutralization, I want to make them neutral. So basically, neutralization means making an alkali neutral, making that neutral, or making an acid neutral. That's what neutralization means. Okay. Now, we can say neutral solution is water, but it is not the only neutral solution. Let me show you a lot of things. Okay, so this is a good idea. So here, Mesam, you asked a question and I'll answer that for everybody. I think my thing is double tapping. That's what's happening. Yeah, somehow my pen is double tapping. So if I give you by name, so I say something is an acid, something is neutral, or something is alkaline. Okay? I'm going to give you a list of things, and I don't want you to worry about how much acidic or alkaline it is. I just want you to know, tell me which of them is what. Okay? So for example, let me just, okay. Oh God, what happened here? So let's say I give you, okay, see, something is strange happening with my new pen. So, we've seen the regulars, we've seen HCl. Okay, what am I doing? You've seen HCl, we've seen HNO3, we've seen NaOH, we have seen ammonia, we have seen water, right? So we've seen all of these guys. Okay, Aisha, we'll get that. Again, when we want to do acids, we'll talk about that. There's no exact range. There's anything towards 0 and 1 is acidic. Anything towards higher than that becomes weak and less strong. So it's a trend, it's a gradient. There's no hard cutoff. It's like asking me, sir, is 80 kilos fat or 70 kilos fat or 60 kilos fat? Is it 63 kilos fat? Is it 75? Is it 85 kilos? Is it 80? Does it 88 kilos make you fat or 87 kilos? It's a range. It's not an exact thing. Only this is what is fat. That kind of thing. I hope you get that, what I'm saying. No? Okay. Yeah, we got your... I got the guys back on YouTube also here. So yeah. Hi guys on YouTube. Sorry. The black screen is back, Pika. Yes. Okay. Okay. Now, for those of you who are here with me right now. Okay. So anything with H plus sign is acidic. Anything with H plus sign is alkaline. And those with neutral are neutral. Absolutely. So here, now here HCl is an acid, HNO3 is an acid, NaOH is alkaline, ammonia is alkaline, water is neutral. Now iske alawa, when I give you this, let's say I give you wrong tool, MgCl2, what would that be? If I give you पोटेशियम नाइट्रेट, सॉरी देखो कुछ मसला हो रहा है इसमें. So magnesium chloride will be neutral. Potassium chloride nitrate will be neutral. Anything that is not an acid and not a base is neutral. पानी हो या कोई salt हो. Yes, thank you Harun. Pika, hi. All right. So ठीक है. So okay, now it's a good question. I'll answer that. How is ammonia alkaline? So now eventually you will do equilibrium with me, and so you'll know how is it alkaline. But let's say I have to teach you, because we will get there, but you have to take my word for it that ammonia is a weak alkali. Okay. Now how do I know that? The way I know that is, when I mix ammonia with water, it dissociates, but you could say it ionizes in water, but just a little bit. Okay? These dotted lines means just a little bit. We will do equilibrium later, so I don't want to get into that, what these arrows mean. But the reason why ammonia is a weak base is that it has low OH ion concentration. And we'll do weak and strong acids. Alright. Thank you, Harun. That's very, very good to know that I could help you out. Okay. Awesome. Thank you. Yeah. That's for people to see your name is on this there. Yeah, by the way, all of these acids are aqueous. When I say acids and alkalis, I mean aqueous. Okay. So Saad. So the how part is done later. I've got to really do that with you guys later. Understand that? What I'm telling you is that anything that produces OH minus ions is alkali. Anything produces H plus ions is an acid. Okay. And you can produce, so for example, HCl. Okay, now like, if you got to take my word for it that ammonia, oh come on, this is all right, and we'll do that later, is that aqueous ammonia. So ammonia, actually some people in O levels write aqueous ammonia as ammonium hydroxide. So it's easier to see the fact that you are going to get OH ions. You see that? And so that's another way of writing aqueous ammonia. And so it has OH minus ions. I'm glad guys. Okay. Now, where was I? So does an answer for now, does an answer suffice, so I can continue? All right. ठीक है. So हाँ, अब मुझे कुछ सवाल पूछने हैं, because this is important, because so if you have, let's say, solutions, I'm sure it's easy to find this, but if I have solution P, Q and R, okay, यार तो font ही छोटा हो रहा था थोड़ा सा. So let's say I have P, Q and R, and the pH of P is 8, Q is 11 and R is 13. Okay, 11 and 13. Which of them in this case is most alkaline? If I ask you guys. Awesome. You guys got this. R. Yeah? Yeah? Now that's one thing. Now, let's say I give you 3 other solutions. Let's say I say, okay, I have VWX and इनके pH हैं 2, -1 and 5. Which of them is the strongest acid and which of them is the weakest acid here? Yeah? Anybody? So the one that's -1. The strongest acid is W, and this is the weakest acid. Yeah. Like an R was strongest alkali and P is the yep. Awesome. So far so good. Now you need to understand that acids can go in the minus. Okay, so never be afraid that it can go in the minus. Remember that. All right. Now, so when I say want to neutralize something, neutralize means to finish off its acidic behavior or finish off its alkaline behavior. So the way acidity works, or the way neutralization works, let me be more specific. The way neutralization works is that neutralization is when you can remove an H plus ion by reacting it with O minus ion to make it into water. That's what neutralization means. And H plus ions from acids react OH minus ion from alkali to make neutral water. This reaction is known as neutralization, meaning that if you have alkali, you can add an acid to neutralize it, or if you have an acid, add alkali to neutralize it. So in English, acid plus alkali becomes water, and this is neutralization. All right, understand? This works out. All right. Hi Sachin from India. Sachin saying hi from India. Hi from India. Okay, Sachin, hi from India. Hello from India. Hi from Saudi Arabia. How from everywhere, baby. Anyways, where was I? I'm going crazy here. Okay, so no. So what do you mean by farwa even in salts? No. Water. No. Adding water does nothing. So let me say it in English. Okay? Let me say it in English. What am I saying? Okay, एक तो बार डबल हो जाते हैं. क्यों हो जाते हैं समझ नहीं आती. ठीक है. So if you have an alkali, ठीक है, to the alkali if you add acid, you can neutralize it. It can make neutral water. But if you're an alkali, you add water, it still stays as an alkali. Remember that. Nothing happens. You might want to add a salt to an alkali. What will happen? It will still stay alkali. So if the pH, okay, let me say it in better. Actually, let me say this a little better. Okay? Okay. Yes, so you can add more water, na? There's no rule that you can't add more water. Okay? Yes, Arisha, it will proceed. So Arisha asked a question that you guys can see. My point is, you take an acid whose pH is greater than 7. Right? That's what you know acids to, what am I saying? You take an acid's pH is less than 7. And you add an alkali whose pH is greater than 7. You will make neutral water and salt. pH will be exactly 7. Okay? Okay, now what if you said no, I want to take an acid, because it's an acid, pH is less than 7, and I will add a salt to the acid. What will happen then? Well, really nothing. It'll stay acid and salt, and the pH will still stay less than 7. If I said no, what if I add water to an acid? It might make the acid more dilute and might change the concentration of the acid. It already has water, and you can add more water, and it will still stay less than 7. Okay? No, the number will change. The number can change, but they won't ask you that, because that number changing is part of A-level second year chemistry. They won't ask you that. All right? Okay? Yeah? So in fact, I can tell you this, that if you take an acid with pH, let's say 1, by adding water, you can make the pH 2. Yes. By diluting it, you can make it less acidic. That's what diluting does. Does that answer your question, Aisha? Yes, salt and water both have pH 7. Absolutely. So if the salt is an aqueous salt, then the pH will become that. Yes, Arisha. But if you're adding solid salt, because remember, pani can lower and increase pH by changing the concentration. Pani does affect the pH of the solution. So if the salt is aqueous, then it will affect the concentration. If it's if it's pH. If it's not aqueous, it won't affect pH. Does that make sense? Yeah? The class going fine? You guys enjoying the class so far? Okay, understood. Okay. So now somebody asked me, what does alkaline mean? So the property of being, so let's say alkaline is the property of being an acid. For example, if I tell you that by name, अगर मेरे पास है, I have, let's say, I say solution E is dilute HCl. So what you can say is E is an acid. Therefore, E is acidic in nature. मतलब acidic is his attitude, is his property. But अगर मैं बोलता हूँ कि I have a solution F, ठीक है, we do not know the formula of solution F, but pH is 2. Therefore, we can say F is acidic. Now, obviously, you might say, well, obviously, if it's acidic, then it should be an acid, right? I know you'll say that. And that's mostly always true. Okay? Not always, but mostly always true. Does that make sense? Yeah. Varisha will get to weak acids. Relax. Everybody wants to do everything in 1 minute. Okay. Aisha, Kashif, yes, something like that. Yes. I'm getting there. Do salts have a certain pH? Miral, salts, assume salts have always 7 unless otherwise stated. Rania, we are doing acid bases and the pH and neutralization. So we started off with neutralization. ठीक है, उसके बाद हम आगे जा रहे हैं. ठीक है? Now, yes, all salts are neutral. Unless something called an acidic salt. And I'll talk about that later when we go to salts in a little bit. But generally, most salts are neutral. So far, okay? Is this handwriting fine? Is this readable? Is this good or bad in your Noon Academy platforms? Because I can't see it. Can't see anything how you see it. You know? I can see on Facebook it looks fine, but I don't, or YouTube. It's readable. Is it less readable than last time? Or more? Okay. Yeah. See. Okay. All right. Now, One thing, I don't know, I don't remember if I told you this. I think I did. Okay, देखें, even acids have H plus ions, even alkalis have H plus ions, even water has H plus ions. So the difference is, in acids, the H plus ions are greater in number than OH minus ions. In water and other neutral solutions, H plus ion are equal to OH minus ion in number. And in alkalis, the H plus ions are less than OH minus ions. Okay? That's something that I need you to know as an idea. All of them have H plus ions, all of them OH minus. So it'll come in handy when you do this in A levels also, and to know this right now, because people don't tend to learn this or understand this. And पानी में दोनों होते हैं but equal होते हैं. Okay? That's what we have for water. So far okay? Now we go to strong and weak acids. If there are no more questions about this, I'd like to talk about strong and weak acids. Is that something that we can do now? Yes, okay. ठीक है. Now I got to get you guys a nice little diagram, a nice beautiful picture. Now, this is it. I hope I can get it. Yes, I can. Clean shot. I have to use a lot of apps to get this going for myself. I'm a very app guy. Okay, now capture area. Okay, save. Okay, so now can I see this? So let's talk about strong versus weak acid first. Okay, then we'll go on to the diagram. So where was I? So what's a strong acid versus weak acid? So we've seen acids. So I want you to know that acids can be classified. So acids can be classified as strong acids or weak acids. Now, yes. Now, by definition, what's a strong acid? One that completely ionizes in water. Now, so let me show this. Okay, sorry. So strong acid is who? One that completely ionizes in water. Completely what does it mean to completely ionize? That means they break up into ions. So what does it mean? All molecules of the acid break up into ions. And as a result, they do what? As a result, they have, okay, 1 second. They have a high concentration of H plus ions. All right. Okay, Rahul, there's nothing called acidified KOH. Acidified KOH will mean adding an acid to KOH. Okay, Ali Abbas, I don't want to use the word dissociates. I want to use the word ionizes. Ionizes implies that there are going to be ions made. All right? Is that okay? There's no molecules of acid remaining though. Absolutely. So, matlab ye, and you've got that right, कि if you take 100 molecules of HCl, add it to water, then it will make 100 ions of H plus ions. So, an easy way to understand this is that if I could quantify the number of, what do you call it? The number of ions. So, for example, I take HCl and I take 100 molecules, even though we know we can take a lot more and are more, but let's say for the sake of argument हम सिर्फ 100 molecules of HCl लेते हैं, gas, ठीक है? Or when we bubble those 100 molecules of gas through water, we say that all of them ionize, meaning you will get 100 ions of H plus and 100 ions of Cl minus. That's what we get. Could you go back for a second? Yes, I could, Hassan Shah. Absolutely, son. You mean this right here? Absolutely. Yeah. All right. Sorry about that. Yeah. Okay. Then where was I? Okay. So, can I go back? Saad? Yes, because nothing technically becomes 99%. If it's strong enough, it'll become 100%. What we have is the other form. You don't get... theoretically, you would be... Practically, you would be right that it'll be a strong acid. But theoretically, only and only at 100%. But it never is a problem because, you know, even if something is 99%, we tell you it's 100%, even though it's 99%. But we tell you it's only 100%. That's the thing. We mess with you. Okay? So this is a strong acid. What's a weak acid? Now, there are many weak acids, but let's say that a weak acid is, what does an acid have to have? An acid has to have an H plus and an anion. Let's say I just write HA as an acid. And I'm telling you it's a weak acid, right? So maybe I write on top, it's a weak acid, right? So meaning, if I take 100 ions of this, 100 molecules of this acid, practically speaking, you know, in the real world, if you add it to water, only about 2 ions are formed each. Now, in the above's case, in the HCl's case, how many HCl molecules left? Are 0. In this particular case, after ionization, number of HI left would be 98, not 96, 98, because 92 became 2 and 2, na? Not 4 became 2 and 2. Ratio, Mesam ratio. So that's called a weak acid. This is, by the way, what happens. Vinegar behaves like this. This is actually vinegar. Only, you see, we call this 2% ionization, because 2 out of 100 is 2%. You see that? So, You will not have to worry about even in A levels that there'll be a percentage. They won't even ask you for a percentage. Now when I said vinegar, the vinegar in the real world is called ethanoic acid. Now we haven't done organic chemistry, but we have done bonding. Okay, Rania, because 2, sorry, what am I writing? 2 became 2 and 2. So out of 100, only 2 reacted. We had 100, but only 2 reacted. How many left? 100 minus 2, which is 98. Now, so where was I? Now, so you have to know, at least for now, learn this as a weak acid. This is called CH3COOH. It is ethanoic acid. It is by far the most popular weak acid, meaning when it ionizes, it only partially ionizes. Partial ionization, meaning only a small amount of H plus ions is formed and the remainder is the anion. Anion kya hai? CH3COO minus. Do you follow? That's the anion. So far, okay? Yeah, so when we do equilibria, this is how we write it, because we know it forms an equilibrium. We haven't done equilibrium, so I don't do that. But okay, for those who are very particular about its equilibriumness, this is what we have. And this is a sign, and it forms H plus ions, and it forms anions, and this is a weak acid. Okay. So yes, you could say this is only for weak. So this arrow that we have made, yes, you are absolutely right, Aisha, is for weak. You asked some good questions, Aisha. I am very happy. This is only for weak. I like a dotted line. You do not have to make a dotted line. So let me show this to you in a diagram. So what I was saying was, you don't have to make the dotted line, but you have to draw this. I'm doing it on white because I want to show you the diagram also. The CH3 COOH makes, you can write the anion first if you want also, or you can write the cation first if you want to, the H plus ion. But this is a weak acid. All right. This is an easy example, Arisha. Other examples are basically, there are no, okay, there is one, HF is a weak acid also. Okay? It, instead of HCl, HBr, HI, HF is a weak acid. Okay? There are other acids like, let me say this, H3PO4 is a weak acid. And when it do this, it doesn't ionize completely. But H2SO4 is a strong acid. So H2SO4 is strong. So when that ionizes, it does make 2 H plus ions and 1 sulfate ion. Strong. ऊपर था HF के साथ HBr कर लो. also from group 7. That is a strong acid. And you will have to just learn them. Yes. So some weak and strong acids, you have to learn them. And one easy way to remember that is that you have to learn them. Like literally for O levels, it's simply this. For O levels, all you have to do is learn this. IGCSE and O levels. All you have to know is that strong में कौन सी हैं and weak में कौन सी हैं. And strong में है HCl, HNO3 and H2SO4. That's it. That is it. So everything else, and sorry, HBr. But you don't need to know that. But weak, no, that's not Aisha. They're also, so above the yellow line is what you have to know. Is that all organic acids are weak. But not all weak acids are organic acids. Weak acids are reversible only. That's why they are weak. If they're not reversible, they will not be weak, Arisha. Synthetic? Synthetic is man-made versus naturally occurring. So if man makes something, it's called a synthetic. Okay. So organic can be synthetic organic or naturally organic also. That's the problem. Olden times we thought organic can only be natural, not man-made. But now we have synthetic organic compounds. Polyester is synthetic. Nylon is synthetic. Those are man-made, synthesized by human beings. That's the term. Now, organic acids के अलावा भी weak हैं. HF weak है और H3PO4 weak है. You don't need to learn this, but it's nice to know. So these are also weak. But for the exam के लिए you need to learn that organic acids are weak and these three are strong. That's it. Alright? Organic have carbon. Yes. There's also another weak acid, carbonic acid, H2CO3. Yeah. Yes, Arisha, absolutely. Now can I show you my diagram? I've been dying to show you the diagram, and desktop. Yeah. So this is basically what it means to be a strong acid versus a weak acid. On the left hand side, you notice HCl ke yellow molecules hain first. Now let's call that, if I can label my beakers, let's say areas, let's say 1, 2, 3, 4. Now beaker 1 में जो है ना, that's unionized HCl. ठीक है? So the yellow molecules are when they're bonded together. And only when you add water, do you notice every single ion is separate here. You see, into every single ion is separate because वो strong है. And a weak acid, ethanoic acid, जो pink वाले हैं, the pink wale are unionized acid. But when you add water, most pink remains pink. Only some pink becomes blue and white. So this is partial ionization. Alright? Capish? Alright guys, I'll have to end the class 3 minutes early today, just for, okay? If that's okay with you. Yeah? Can I? Yes, obviously, Miral, there is strong and weak alkalis too. I'll just give you by name quickly. So, basically, what we realize is that NaOH is strong, KOH is strong, calcium hydroxide is strong, and the only weak alkali you are to know is ammonia. बाकी सब आपके लिए are strong. Metal hydroxides are strong. Alkali. ठीक है? I'm glad you guys had a good class. ठीक है? I'm gonna head out now. I hope this was fun. I hope the black background was more fun than the white. But I'm getting a new tablet today, so I hope this worked out for you guys. You know. And I'll see you guys shortly tomorrow. ठीक है? Bye bye. What are alkali metals, Sabiha? We have had 2-3 classes now. Group 1 metals. Group 1 metals. Alright guys. Ciao. Thank you very much. I love you all. And it's been fun so far. And yeah.